Okay, let's go ahead and get started. So I think for tonight, one of the things I want to do is get it so that, let me get some sample output here real quick. So I have it now where it runs through each test, and then if it fails, it'll put a little arrow next to it right there, just so you can distinguish easier which ones are passing and not failing. But when I get to using this with a whole bunch of different tests, like on the order of like 200 or something like that, I still get really messy. So it'll still be nice to have like an output of what all is happening. But at the end here, what I'm really interested in is how many are passing and how many are failed. And right now I have it so it's just a count of how many actually failed. So it's not really giving me any useful information, and it'd be too much to scroll up and down here to find which ones actually failed. So I think what I'm gonna do is make sort of a test report structure so that at the very end I can pull out which ones passed and didn't pass. Actually, I think I'm just going to log the ones that didn't pass because that's all I really care about. And then down here at the testing report, I can have some more information about that. So I think that's what I'm going to do now. I did get it working so that you can have the tests in a separate file. So I was kind of looking into gtests and boost tests to see how they registered their tests and all of that. I kind of followed the same structure as Google Tests, where you have like the test and then the name of the group that's within and then what the specific test is. That's the kind of structure that I followed. One thing that Google Test has that this doesn't is it automatically registers each test when you call this right here, and the way it does that, from what I could tell just reading through the source code, is in C++. When before main runs, it's possible to do an initialization of all the objects that you have. I think that's how they do it, is when the initialization is called of the object, then it actually registers each test prior to main running. But since this is going to be strictly in C, there isn't really any way to run tests before the actual program starts. So really the only way to do that is you have to register each test manually, which kind of sucks because then you have to make sure that names up here match with the actual ones that you're registering, and if you change the name then that'll get messy. But that's really all you can do, so I'm just gonna kind of leave it how it is. So I was kind of picturing each file would have like tests that are related to certain set of source code. And really the only thing you need is an entry point into that file. So like in main, I have this right here. It goes over to the test file, and it sets up all of these down here. And that's kind of how that works. Oops. So I think I'm going to keep that like that. So this is all working kind of how I want it to. Right now, the only kind of test I have is the expect true. So you can see down here, running these tests, it says these two failed because it was expecting a true, but it was a 0. So there's quite a bit you can do with just those two. What is going on here? Looks like this stream is lagging a little bit. I guess the network's crappy or something. anyways, where was I? Oh yeah. So right now I just have the expect true. These are defined in B test starts right there. It's right there. So that's that. I think another one that I'm gonna make next is probably a comparison one. So like expect equal, and you could pass in maybe 2 integers, and it'll check if they're equivalent or not. I think those are the really only 2 I'm going to make for this library, because you can do pretty much anything with those 2. So yeah, let's see, what do I want to do first? I guess I'm going to kind of start making this test report thingy work. So the way I have it now is when the expect true is run and it's checked, if the value is true, then it'll update the test status. This is kind of where that this little counter right here gets updated with the number of tests that passed and failed. I think in here is where I would update that the test report structure stuff. I think I'm gonna have it like a linked list, kind of like the tests are all strung together. That way I can just walk down it at the end and see which ones pass and which ones failed and that sort of stuff. So I guess the first thing I do, let's make a function for adding on test report. Let's take in test report node. Let's see. I think what I might do here actually is just pass. Let's see, do I want to pass it? So the test report is going to have an explanation of what failed. Trying to figure out if I want to make the node and then add it in. I guess that, yeah, that makes sense. Okay, so I will pass in test report node. Oops. I'm wondering if I should just make so I kind of already have like a linked list thing here. I'm wondering if I should instead of just copying it again, if I should just make a linked list function thing. Trying to think if it's really necessary or not. This would be easy with C, because then I could use, or I mean C++, because then I could use templates and stuff. But with this, it's kind of specific to the actual type you're passing into the linked list. I don't know if I should do that or not. I guess not. So let's go ahead and make I think I might just shorten this to like R node or something for a report node. Yeah, let's do that. Okay. Maybe port head, and we're gonna start that off at null. So if actually, I'm just gonna copy all this down here because it's pretty much the same idea. Oh, we're gonna name it the port head. What is it complaining about? Oh, wait. Oh, oops. There we go. Okay. Anyways. Porta. Node. Okay. So if I call add test report node, alright, that looks all good. Trying to research if there's like really a way to, because I feel kind of weird copying and pasting like pretty much the exact same code twice here, but I'm trying to think of a way I can avoid that by just writing one function that can work for both. But the thing is, the structure of each of these is a little bit different, so it works differently. Like in C++, I would just use a template sort of thing, so you could pass it in any object. But I'm trying to think of a way I can do it with just C. So I'm looking through some libraries here. There's not a standard one that comes with the GCC or whatever. I guess that's the downside of working with C, is you have to remake everything. So I'm just kind of looking through some libraries here. You know, maybe I could... I could have like just a generic node and then like a linked list container sort of thing. So then and then inside of that container you could just have the next pointer and then like a memory pointer, like a void pointer to I'm zoning out the actual, not object, this isn't C++, the structure or whatever, so that way I can keep it generic. Trying to see how everybody else does it. Yeah, so it looks like some people do it that way, some people don't. I think that's what I'm gonna go ahead and do. That way it doesn't get too messy. So do I want to do this in a different file? Probably should. Trying to keep everything kind of with just a few files, so you only have to import so much. So I think I'm gonna go ahead and build it in here. And I guess later I can pull it out if I need to. So let's see. So all right, let's redo this. Okay, so type diff struct. Name it list node. Okay, so in here, I'm gonna have just a void pointer that'll point to the keep wanting to say object, but it's not object. It's just just a variable, whatever. Okay, so anyways, back to this. I'm going to go ahead and call this like data or whatever. And then I'll be able to hold a pointer to and the problem with that is you have to locate the object. I guess we're gonna have to deal with dynamic memory anyway, so I might as well. So just call it that. Yeah, you can't assign it. Oops. Okay. And then all I need. Ooh, let's get this name. Let's call it listen. So struct list node next. All right. I don't know why this stream is really lagging behind. Looks like it's like 10 seconds to run. It's not too bad. All right. So I think that's really all I need for the node. That should be good. Let's kind of separate this out a little bit. Oops. Okay. So these data structures are going to change a little bit. They're not going to have a next pointer inside of them because that's now going to be taken care of by this. Okay, I'm a lot happier with that because that'll be way cleaner. Okay, so we want to have a function to LL for linked list, add node, and then let's see. Yeah, it's like a okay. Alright, so do you want a pointer or a pass them? Actually, add node. So I guess all we really need here is just data. For this particular linked list, I'm really interested in adding stuff and then tearing it down. So I don't really need to worry about where I actually put the object. So it's just gonna go at the let's see, the tail or head, depending on which way you look at it. The end of it, at the end of the linked list. So in that case, let's go ahead and take this code that we've been copying and put it in there. Okay, so in this case, we really only need, well, let's see, how do we want to do this? So I guess we want a pointer to the head too, so we can know which list to add it to. So that'll be a list node. So we give it the head, and then it knows which one we're talking about. So head equals null head. So in this case, this is where we can, okay, so we pass in the data, then we can set up the head, I mean the node that we're linking up. So no matter what, we're gonna have to create a new node. So let's keep that out of that if case. So like a node new node equals is that gonna, so if I trying to figure out, do I need to put in some information, because this data pointer could change. Wonder what the size of a void pointer is. Would it be defined before you set it? Okay. Okay, so this is actually defined. The size of the void pointer is based on the size of your system. So like if it's a 32-bit computer, I think it'd be just like 4 bytes long or something like that. So it'll know when I allocate this new node, everything's going to be defined there. So we'll be good. So size of list node. Oh wait. Okay, sorry. Size of list node. Okay, I don't know what I was thinking there. I'm tired. Okay, this is going so slowly. Okay, so going to do okay, so head, if head equals null, then I'm gonna set the head pointer. Ooh, do we wanna you know what? We might need to do that. So so the pointer is messing with my head. So I dereference that once. Because in this case, I actually want to change, or do I? Yeah. Okay, let's try this. Okay, so the head. So I actually want to change the head pointer, so I'm going to have to pass in a reference to the head pointer. So head equals new node. Does that make sense? Okay, and then head. That's next equals null. Okay. And okay, so that's the case if the head is empty. And then down here, list node, make current node equal to head dereference net. This is a good song. Current node. Next. No, current. Actually, we don't need that anymore. This is much cleaner. Okay, so then I'm using camel case over there, not over there. Let's change that. I can never decide if I want to do camel case or using underscores. I think underscores makes a little more sense. It's easier to read the word. New nodes next. Current node next. Okay. So I think that should do it. Let's test this out real quick. Let's see, what's our entry point over here? Let's go back to main. Take that off for a second. So coming over here. Okay, I just want to test that linked list real quick. Alright, so what do we need to test this? So we need a new list node. Cool node. Alright, cool node. Dot next equals null dot data. Let's make something real quick. Can you do that? Huh. Stupid breakpoint. Okay. And then gonna go over here. So this is where we're gonna set the data. Test data. Alrighty, and then linked list, add node. I guess we need a head pointer. So list node head cool head. Small. Pretend that that is not set initially. And then so we're gonna pass in reference to cool node. And then or cool head I mean. And then we need pointer. Where data pointer. Wait. Oh, that was stupid. Okay. We just need the data. Forgot we're doing it that way. Okay. So pass in test data. All right. Let's see how that turns out. It's a breakpoint right here. Current node head goes null. Wait. Oops. So it was thinking that head wasn't null because we're passing a pointer to the pointer, and the pointer to the pointer wasn't null. So I think that's what that was doing. Let's try that. Cool. Alright. Cool head. Data. It's not working. Let me just do this real quick. Three. Oops. Alright, let's go ahead and inspect what it's doing here. Something weird is happening. Making a new node. The head should be null, and it is. So head equals a new node. Wait, oh my gosh. That was stupid of me. I forgot to set the data. Okay. That's why it's not doing anything. So new node. Data equals data. Let's see how that goes. This is oops. That looks weird. Test data. What if that's because it's a void pointer? So if we let me try something here. T check data equals cool head data. I think I might just be confused about what kind of variable that actually is. I want to view the value as not oops. I want to view it as just what? Okay, let's go back in here. It's probably something really stupid. New node. New nodes, data. What does data look like? Pointer. Wait a second. Oh, wait, no. I didn't really work with void pointers a lot, so I'm probably missing something. Or at least not in this manner. Okay. So it's entrance. Let's see. What happens if you dereference that? Whoa, what the heck just happened? Let's get rid of that for a second. Okay. Let's clean some of this up. Okay, so what is here? What's going on over here? Okay. I don't know what I'm doing here. No, that was correct, actually. So the problem here is getting the data to work, the void data pointer to make sense. Check. Okay, so that's working then. So then. Okay. Okay, so then let's make. So actually, I think that might have been working okay. Xcode is getting very buggy. Okay, so let's try this down here. And I want to do Cool. Okay. So that seems to be working. Okay, so I just wasn't dereferencing it right. I guess that makes sense. So you have to get void pointers to work correct, you have to first cast it as. Oh, okay. So that's okay. So this is the void pointer right here. This right here, and I'm casting it to an integer pointer. So then this whole thing right here becomes pointer to an integer, and then you can dereference it. Cool. Okay. I'm gonna make a note of that at the top because I'm gonna forget that. But yeah, it's working. You can kind of see down here the data check was value of 3, which is what we were looking for. So dereference. Yeah, that's right. Okay. Dereference a void pointer. Okay. So yeah, that makes sense. Because then the system wouldn't necessarily know what kind of a pointer that memory address, or that whatever that memory address really is, without defining it. Okay, that makes sense. It was kind of weird notation, but if you kind of imagine it like you're casting it, like just like you normally would, but instead we're casting it to a pointer. Okay. Get rid of that. Okay, let's do a few more tests here. Problem with using a void pointer though is that the object will have to exist. So is there a way to take the memory at that pointer and then copy it over? Because I want to have it so you pass in a pointer to the data. You're passing the data. I wish you could just have it like that. But you can't. So let's see if I can copy it. Copy. Okay, so we want to take. That should work actually. So. From there to new node data, and then size of data. Would that work? give it a shot. So that way you pass in the resource, then if the resource disappears, it isn't gonna like totally screw up the data in there, because then it'll just be gone. Going for about 50 minutes now. Cool. Alright, so let's check how that goes. Ooh, yeah, it doesn't like that. Wonder if let's look into that real quick. See and copy Floyd or Floyd data. Should work. It's destination. Oh. It doesn't seem like there should be a reason why that isn't working. Let's try this here. You know what? I think I might know what I'm doing wrong here. I don't think I really located the memory. Okay, new node data equals size of data. Okay, let's see how that goes. I'm so far off track from the actual testing thing. I'm trying to design a linked list library now. That's a good learning experience though. And C, memory management. It's really cool working in void pointers because then you don't have to actually know beforehand what you're storing. Okay, where was I? Data, yeah. Okay. Please work. Sweet. Okay, that was it. Okay, so what I was doing was over here. I just had this line right here, and what I was doing was I was trying to copy memory to a location where the memory wasn't even allocated in the beginning. So, okay, so I need to make sure that when I tear down the linked list that I actually delete the data within here too, or else that'll be a memory leak. Okay, so that's working. Let's just make sure that our linked list is working the way it should. Test data 2 equals 6. Okay. Should be 3 and then 6. We got 3 and then 6. Alright. So now let's take care of tearing down the linked list. Trying to think, is there a situation where I want to delete just one node? Don't think there is, because we're just going to have all of our data, we're going to be adding it in, and then once we're done with it, we're just going to take it all down. So let's get that working next. So I think this is kind of how, okay, so I have the tear down like this. You guys want to do it like that. So I gotta, before I forget, gotta make sure I delete the data within that. Where did like this go? Okay, this node equals, oh wait, I gotta make a function first. Okay, list tear down. And we want pointer to the head. That's all we care about, just where the head is. List node, current node equals head. List node, this is the one that trails behind it. So we kind of had to keep track of the one that's behind it, so that, because if we delete the node that we're on, then we'll lose track of where the pointers are to the one in the next in series with it. So set that also to head. Trail node equals current node. So inside here, wait. Okay, so you want to free trail nodes data. Okay. Delete the data that was located. Okay. This isn't really necessary at the bottom here, but it's good to set it to null because sometimes free doesn't happen right away, so then the pointer looks like it still exists when it really doesn't. So that just kind of makes sure there isn't any undefined behavior. So lengthless Terpan. Alright, let's see if this works. Make sure there's nothing that crowd. Oh yeah. Good. Passing good. Cool. All right, that worked. Memory. Cool. No memory leaks. So that's that. Get rid of all this junk now. Okay, so now that's all working. Okay, so over here you know what, I think I'm just gonna keep those as nodes. Okay, so delete that. This right here is a function. Let me make that clear. Okay, so that works as before. Do we want to make an iterator of some sort? Let me research a little bit about how that works. Lengthless iterator. Okay, so I think what I'm gonna do here is have want to get a return a pointer to void pointer. Let's see. length list get. So basically what this is going to do is it's just going to get, you're going to pass in a position, 0 would be the head, and then on from there you get back the other nodes. So and then it would pass back null if there's no node at that position. It's not going to be kind of slow though. I'm passing the head too. Okay, it looks like that's pretty good. Okay, so length list get, and then
just as you go over any other waterfall, just as you go on from day to day, just as you go to sleep at night. Be absolutely willing to die.
okay, this playlist is getting kind of boring. Let's see if I can find another one here. I like this playlist. Okay. Okay. The only problem with this is, I guess if you're kind of searching for stuff, it could end up taking quite a while to go through it. I'll leave it just that for now. There's a few efficiency things I could do, like if it calls it twice, and then if the position is just one greater than the last one, and we stored the last position, that might be good. Let's start with this though. Okay, so node current node equals head. So if it's 0, 0 is less than position. Zero is less than. So if we pass in 0, we just want to get the head. Current node.
Those hazy days I do remember. We were running still, had the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand open arms. This is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadows in the trees, holding on, memories never change.
So, what I'm doing here is making sure we don't, like, can I just move this up to the top here? So I'm making sure is that if we enter in, we want to get a position that's greater than the size of the linked list, that we don't end up iterating past that null pointer. We want to just return that pointer. So So if it's 2, 0, we do 1. Current node next equals null. Okay, so the logic here is that if we're on a node whose next is null, and we still have more to go, then we want to just say that. Okay, we also need. So we want to say if we still got to iterate upward or down the list, then we just want to stop there and then return the null. Otherwise, then we can keep going down the list. Okay, so it's gonna be a problem now. All this code is gonna be I should have left that stuff up there until I was done. Okay. I'm just trying to turn off all this stuff for now, since I'm just testing. Okay, so now we have just the linked list, and then reference the head, reference to test data. Okay, so now if we give it the head, we tell it we want node 0. Okay, that should work. Oops. Yeah, now it's complaining about all the defines because all that stuff's messed up. I'm just gonna put a little strength back in here. Alright, should take care of that. Did that really just work? Huh. It's a miracle. So, make sure. That gave us right. Well, that was easy. Okay, and then if we want the, so this should give us null. That case, Wow. That's cool. It actually works. Okay. And then pass should also give us null. Sweet. Okay. Set in. Actually, it'd be cool. Okay, this way we could also test to make sure that it's actually copying in the data. So this should give us back 6. Wow. Cannot believe that actually worked. If we get 0, we should have 3. Sweet. And if we get back 3, this is gonna crash because but our node is null. Alright. Okay, now we can switch stuff over, I think. Okay, so now okay, so while linked list get head Alright, linked list. Okay, now let's go back to switching this stuff back over, so list node. Wait. Okay. Here's what we need to do. Compare it to so we get to the list node. It's gonna be messy. And this is going to be a type of test node. Or T-node, sorry. Okay, then we can get the name. Okay. Okay. Then we're gonna reference the test head. That's our data. That should be all that you really need for that. Oh wait. Okay. And that'll be the same for over here. See, that way you don't have to copy and paste a bunch of stuff. Test, and test node. Let's add node. First the test head, and then node. So this is where that efficiency thing comes in, because for each one of the times that you run the get, it'll you'll have to search through the whole list. So I think what I'm going to do eventually is have it make a note of that. So in here, make Okay. I think this was, okay, so we gotta tell it what kind of pointer it is, so it's it's a T-node. And then we want to get back its name. Oh. Okay, anyways, and then down here, same thing. Okay, let's kind of walk through to see how it's working out. Wait a second. We update the ad test. Oh, duh. Let's see how that's. Okay, that's running. Okay. I'm gonna be amazed if this works on the first try here. Yeah. Okay. Let's see how this is looking. It's kind of messy, so I'm gonna bring this out of here. Let's see. Before we get there, data. I wonder if it's because it's not copying. So when it reads the size of, so when the length was, let's see what the size of that is. I have a feeling it's only copying 4 bytes because it's reading the size of the void pointer, which is only 4 bytes. It's not reading the size of the data, which would make sense. So maybe we need to pass in the size of it too. Okay, that might be it. Okay. Size of data. I bet you that's going to be 4 bytes big. Eight bytes, yeah, okay. That probably doesn't vary. Yep. Oh wait. Yeah, that's always 8 bytes long, which is kind of what so yeah, 64 bits. Yep, that's just the size of the memory register. That's what it is. Okay, so we also need to do over here. Data size. Alright. See how that runs. There we go, that's looking much better. What initially tipped me off to it was this down here. I guess my face is covering it, part of it. The name was only a few letters long, I think like 8, which made sense because it was copying the size of the void pointer. It had no idea how big the actual data was because I was just saying, hey, how big is the void pointer, which is always going to be 8 bytes long because that's what the system has it as, which isn't the size of the actual data. So let's see how that runs. Still crashing. We're getting there though. Okay, so test pointer looks right to me.
Let's go, baby,
Is that syntax right? Why is it saying running 0? Let's do this. That's weird. Oh, wait a second. I see what I'm doing here. Okay. Wait, okay, so... Okay, let's start over. So this is actually not returning void, it is returning a list node. That's what it was. Okay. Data. And then we can cast it to T-node pointer. Alright, let's see if that does it. Alright, running test external testify. Please work. Alright, it works. Sweet. Alright. Let's take out that breakpoint. Looks like it's running through an infinite loop. Test external. So getting. Oh wait. We're probably not setting the next pointer to null. Okay. Hopefully it's that simple. No, we have it down there. Can't be it. So where are we looping around here? So I'm gonna report an into. Oh wait. That's the problem. Cool. Okay. Okay. Wait, would it be? What should I save the history of that? No, I don't think it would be. So if we're at null. Let's see what it's saying again. Tested. Oh wait. Okay. All right. So. Okay, I think that was it. Got 2 failed, pass, shoot, failed, pass, 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 pass. Alright, I think that might be a good stopping point. About to hit 2 hours now. So, fortunately I didn't get enough time to implement the report. Don't need that anymore. Don't need all this. Alright, that'll make things easier. I guess it ended up taking about the same amount of code, but flows a lot nicer now. So let's see. So that should be... let me go ahead and get this part working since that's the only other part. Okay, so... Oops. Oh, I'm doing it over here too. Okay. You know what? Wonder if it should be that.
As we gaze up at the stars above our heads, in their cosmic glory, while all the world is turned inside their heads. I don't know if we'll ever see each other again, or when we'll meet once, but please, just let me hold your hand.
This is probably gonna create a lot more problems. Hopefully it just works. Okay. Alright, that's okay, so if current node equals null, turn null. Oops. Sweet. Okay. Should probably stop before I make more problems. Okay, so failed, failed, pass, failed, pass, failed. Okay, and then the test report seems to be working. Okay. Let's just clean a few things up. Alright. Pretty pleased with that. We're gonna go ahead and end it for tonight.